Welcome back to the course Introduction to Green Process Engineering. Today we are going to focus on the textile industry. We will first have a look at the status quo and then move on to the strategy defined in the transition path of the European Union before giving some examples. The textile industry is a significant sector in the European Union that is characterized by its complex supply chains and substantial environmental impact. Let's have a look on some numbers. Annually, the European Union produces 16 million tons of textile waste, of which roughly 26% are recycled, 36% are discarded, and 38% are incinerated or landfilled. To translate these numbers to an easier format, the 36% discarded textiles are 5.8 million tons, leading to 11 kilograms of textiles that each of us discards annually. With respect to the worldwide discarded textiles, each second, somewhere in the world, a truckload of textiles is landfilled. Textiles are a growing market, clothing being the main driver for market growth and also having the highest share with 81% of the overall growth rate. One reason for the growing market of textiles is its decreasing price. Between 1996 and 2018, clothing prices in the European Union decreased by over 30% related to inflation. This has led to an increasing quantity of textile. The quality of discarded fabrics and textiles, however, is decreasing due to the trend towards fast and cheap fashion. What now is the strategy of the European Union to deal with increasing textile waste with lower quality but higher complexity? You can imagine that just one measure would not be enough to treat such large amounts of complex textile waste. Therefore, the European Union has a multifaceted approach. In detail, the multifaceted approach means that we need circular textiles, which include the development of an eco-design for textiles. In the eco-design, the different levels of textile value chains are addressed. For a start, textiles need to be designed for longer lifetimes. The improved durability will support circular business models like reuse and repair. A focus is drawn to non-toxic circular products from sustainably and ethically sourced raw materials. Also, microplastics is a topic in the eco-design, as textiles consist of roughly 60% of plastics. Measures for limited microplastic release are not only relevant for textile recycling, but also for manufacturing processes, pre-washing, labeling, promotion of innovative materials, washing machine filters, and wastewater treatment. Eco-design does not only concern the design of textiles, but also producer responsibility, which means stopping the destruction of unsold or returned textiles. Here, a transparency obligation for large companies to officially disclose the number of products they discard is proposed. Last but not least, a product passport should be introduced to ensure traceability and transparency. If you want to know more about the eco-design of the European Union, then you can find more information on the website of the European Commission. As a take-home message, we can say, fast fashion is out of fashion. A topic outside the eco-design is the separate collection of textiles. At present, just 38% of textiles are collected separately. Already by 2035, recycling rates of at least 65% are targeted. Advanced sorting and recycling technologies are vital for promoting textile circularity. Which technologies are now in focus when textile recycling is implemented? Here you see an overview of the different recycling technologies. The first step in each recycling route is collection and sorting. Sorting involves the separation of metallic parts and wet waste. Technologies such as near-infrared spectroscopy allow for the classification of textiles, for example, into synthetic, plant-based and animal-based fibers. As already mentioned, the mix of different origins of fibers makes sorting and hence textile recycling challenging. After sorting, pure fractions can be mechanically recycled. The sorted textiles are washed and shredded and then spun to create new yarns or blended with virgin material. However, mechanical recycling cannot be used for synthetic fibers. Further, often the fiber quality of the recycled fiber is lower than the quality of virgin fibers. The second recycling route is thermomechanical recycling. It is based on the remelting of thermoplastic materials. During the melting process, the textiles are broken down to their polymeric state. This process already exists on a commercial scale in principle, but not for collected textiles. There it is still in demonstration scale. Textile companies internally recycle their product waste using this technology. Both mechanical and thermomechanical recycling requires pure fractions. Chemical recycling, the third recycling route, breaks down the fibers into the monomeric or polymeric form and allows for the creation of virgin-like fibers. Chemical recycling includes methods such as hydrolysis, glycolysis, or methanolysis, where the fibers are brought into contact with chemicals and are then separated into the single constituents. The isolation of these constituents as well as chemical recycling are still not easy and make textile recycling costly. Biochemical recycling employs living organisms or biochemical processes to decompose textile waste. This approach often involves the fermentation of natural fibers, converting them into simpler compounds, for example sugars, that can be repurposed. As an example for a chemical recycling process, you see the Creasolve process developed and patented by Fraunhofer, where textiles with mixed fibers are dissolved with a solvent before impurities, such as metals, are isolated. Then the fibers are precipitated, dried, and again used as virgin material for fiber production. Thermochemical processes are processes such as pyrolysis, liquefaction or gasification. These processes are operated under elevated temperature and pressure and inert atmosphere. Depending on the temperature level, heating rate and time, the fraction of the three resulting products, namely oil, char and syngas, varies. However, all three processes have in common that the resulting products are not feasible for fiber generation, but can directly be fed in existing production pathways, for example for fuel or chemicals production. Today I gave you the most important numbers for textile waste and also the defined transition path of the European Union. Furthermore, I showed you recycling technologies and also which products are formed in the respective recycling route. Thanks for watching and I will see you in the next video.